Hello everyone, I'm Dr. Rajesh and I welcome you in this video lecture. In this video lecture, we will take up some more problems on successive differentiation, and the problem that we are taking right now is find the nth order derivative of this one log square root 2x plus 1 by x minus 2, and number 2 3x plus 5 divided by x plus 2. So now this will be I am taking the solving the first problem. So say this is y is equal to log root 2x plus 1 x minus 2, and we know that this can be written as log 2x plus 1 x minus 2 raised to the power 1 by 2, and the property of log is that the power will come before log. So this will be 1 by 2 log 2x plus 1 divided by x minus 2. Okay, so this will be further equal to, use the property of log m by n, this will be log 2x plus 1 minus log x minus 2, close the square parenthesis. Fine. Okay, now we have to find the nth order derivative of this quantity, but here two quantities are given whose nth derivative is to be determined. So I am going to assume this as u and this thing as v, and let us see what happens. So it will be y is equal to 1 by 2 u minus v. So whenever we will do nth differentiation of y, it will be nth differentiation of un minus nth differentiation of v. So it will be vn. So it will be, if I write yn is equal to 1 by 2 un minus vn. Fine. Where you will mention where u is equal to log 2x plus 1. Fine. And v is equal to log x minus 2. So, and I'm going to name this equation as equation number 1. Now we will find the nth order derivative of this u and v, so that I can substitute over here. So, and that you can also easily, if you have any confusion that how yn is equal to un, you will differentiate this equation for one time. It will be y1 is equal to 1 by 2 u1 minus v1. One more time it will be differentiated, it will be 1 by 2 u2 minus v2, and if it will be differentiated n times, simple generalization, it will be 1 by 2 un minus vn. So that is how we have written yn is equal to 1 by 2 un minus vn. So now we will try to determine the value of un and vn. So we have to differentiate this quantity n times. So we will follow simple generalization. You will find u1, this will be 1 by 2x plus 1 and into 2. Now you will again generalize, it will be minus 1 2x plus 1 raised to the power 2 into 2 square, and one more time we will differentiate, it will be minus 1 minus 2 into 2 raised to the power 3 divided by 2x plus 1 raised to the power 3. Now you can easily generalize, you will write the un will be, it is minus 1 square, okay, 1 into 2 is 2 factorial into 2 raised to the power 3 divided by 2x plus 1 cube. It is minus 1 raised to the power 1 factorial 2 square 2x plus 1 whole square. Now you see, whenever here is 3, here is 1 less power of minus 1. So it will, whenever here will be n, it will be 1 minus 1 raised to the power n minus 1. When here is 3, here is 2 factorial. When here is 2, here is 1 factorial. So whenever here will be n, so here will be n minus 1 factorial. When here is 3, here is 2 raised to the power 3. When here is 2, 2 raised to the power 2. When here will be n, it will be 2 raised to the power n divided by 2x plus 1 raised to the power n, because when here is 3, here is 3, here is 2, here is 2. So this is the nth order derivative of u, that is un. Now similarly on the same lines we will find nth order derivative of v. So let me do it. Differentiate first one time, it will be 1 by x minus 2. Differentiate one more time, what it will get, we will be getting, it will be minus 1, it will be x minus 2 raised to the power 2. Differentiate one more time, minus 1, it will be minus 2 divided by x minus 2 raised to the power 3. Continuing likewise, we will get, I am going to generalize from here. Can I write it something like minus 1 square, and 1 into 2 is 2 factorial divided by x minus 2 raised to the power 3. And can I write it something like minus 1 raised to the power 1 into 1 factorial divided by x minus 2 raised to the power 2. So what will be Vn? Look over here, when here is 3, it is minus 1 raised to the power 2. This is 2. Fine, when here is 3, here is 2 factorial. So whenever here will be, when 2, here is 1 less. So whenever here will be n, so it will be minus 1 raised to the n minus 1. And whenever here will be n, it will be n minus 1 factorial divided by, when here is 3, here is 3, here is 2, here is 2. So whenever here is will be n, here will be n. So this is the nth order derivative of v. So I am going to substitute all these derivatives in equation number 1. So what will be the equation number 1? So I am going to rub it from here. Now yn is equal to, now yn is equal to 1 by 2. Put the value of un, this will be minus 1 raised to the power n minus 1 into n minus 1 factorial into 2 raised to the power n divided by 2x plus 1 raised to the power n minus, put this value over here, minus 1 raised to the power n minus 1 into n minus 1 factorial divided by x minus 2 raised to the power n, and close the braces. So what it will be? It will be 1 by 2. Take the common, minus 1 raised to the power n minus 1 will be common, n minus 1 factorial will be common. So here I am going to write minus 1 raised to the power n minus 1 factorial, and inside braces we are left with 2 raised to the power n divided by 2x plus 1 raised to the power n. It will be minus 1 by x minus 2 raised to the power n, and close the parenthesis. So this is the required nth order derivative of the given function log square root 2x plus 1 divided by x minus 2. And you see, in this question we don't have to remember any of the formulae. We just stuck the with the basics and did it without any complicated and sophisticated formula used over here. We simply generalized after 2 or 3 derivatives and found the result. So this is the nth order derivative of the question number 1. Now we'll try to solve the question number 2. Now we take the second problem. So here we see, let us say this is y is equal to 3x plus 5 divided by x plus 2. Here you see, if we will start just differentiating without thinking anything, so we will land nowhere, because when we will be differentiating first time, we will use the quotient rule or the product rule. Then the things will start get complicated and we will not get any element of symmetry, or we will not be able to generalize. So I am going to leave this approach that I will directly start differentiating it 2 or 3 times and will get something. I have very much clear before starting the question that I am going to land nowhere, and this question will be just jeopardized. So I have to just save this question from stucking in between. So what we'll do, here we see, here degree is 1, here is degree is 1 also. So can I carry out the division, long division? Let us carry out the long division. You will write 3x plus 5 and here you will write x plus 2. So it will go upon 3. It will be 3 is multiplied over here. 3x plus 6. It will minus, this will cancel out, so this will be minus 1. So I can write it. I can write 3x plus 5 divided by x plus 2 as 3 remainder and x plus 2. You already know this type of division, and this I can write it as this quotient. So 3 minus 1 by x plus 2. So I am going to put this over here. It will be 3 minus 1 by x plus 2. Now we will try to differentiate it. So I am going to generalize it. y1 will be 0, minus is already here, 1 more minus will come, it will be x plus 2 square. Okay, one more time differentiate, minus is already there, here is minus 1 and here is minus 2 divided by x plus 2 cube. One more time, let us do it and see what happens. Minus 1 minus 2 minus 3 divided by x plus 2 raised to the power 4. Fine, now we will try to generalize. If you want, you could also write one more, but I think it's enough. Minus minus minus, it will be minus 1 raised to the power, it will be 3. 1 into 2 into 3 into is nothing but 3 factorial divided by x plus 2 raised to the power 4 minus 1 square into 2 factorial divided by x plus 2 raised to the power 3. Fine. So now I will emphasize upon one point. Look over here, when y3 minus is here, when y is 2 minus is here. So whenever I am going to write generalized nth order derivative, whenever yn will take, minus will be here. When here is 3 minus 1 raised to the power 3, when y minus 1 raised to the power 2, and when here it is 1. So what I will be doing, I will be writing minus 1 raised to the power n. When here is 3, here is 3 factorial. When here is 2, here is 2 factorial. So whenever here will be n, so here will be n factorial divided by, when here is 3, x plus 2 raised to the power 4, 1 more, x plus 2 raised to the power 3, 1 more. So whenever here will be n, so it will be n plus 1. So this is the nth order derivative of the given problem. Look over here, when we put n1, what will get? You will get this result. When you will put n0, will you get the y because when you put 0, this is y in itself is equal to y 0. So when you put n 0, can you obtain this result back? So let me do it. I'm going to put 0 minus 1 raised to power 0 is 1, 0 factorial is 1, x plus 2, 0 plus 1 is 1. So it will get minus 1 by x plus, so this is y. So this generalized result is true for n is equal to 1, n is equal to 2, n is equal to 3. So now I need to mention over here that n is greater than equal to 1. You will mention it because now result is not holding for n is equal to 0. So in this case it is not holding for n is equal to 0. So I particularly mentioned, because when I have put here n is equal to 0, I should have obtained 3x plus 5 divided by x plus 2, but instead of this one I have obtained minus 1 by x plus 2, and it is not the true case, true picture. So this will be the nth order derivative, and this where the value of n is greater than equal to 1. So here I would show you and explain you one thing that you must give attention to. Look, this result can be written as yn is equal to minus 1 raised to the power minus 1 raised to the power 1. So this will add up, powers will add up, minus 1 raised to the power n plus 1 into n factorial divided by x plus 2 raised to the power n plus 1, and we will mention that n is greater than equal to 1. This could also be written as, can you write it as minus 1 raised to the power n plus 1? Can I write it as minus 1 raised to the power n minus 1 into minus 1 square? That I can do because this will add up again, minus n minus 1 plus 2 will add up to n plus 1. So this will add up and will give minus 1 raised to the power n plus 1. So minus 1 square is 1. So this will be minus 1 raised to the power n minus 1. So this will be minus 1 raised to the power n minus 1 into n factorial divided by x plus 2 raised to the power n plus 1. So whichever result you want to write in the form of the answer, you are free. You could leave it up to here. You could write it in this form also. You could write it into this form also. So that is the successive differentiation of the given function 3x plus 5 divided by x plus 2. And in this video lecture we have dealt with two important numerical problems, and we have obtained their nth order derivative, and that is all I have from this lecture, and I hope that you will be able to understand both these problems. So very soon I will be with you with my next video lecture. Till then, take care, bye bye, see you.